In the previous videos, we built a maturity framework for data platforms. And according to that framework, these platforms scores around 3 out of 5. Not terrible, not amazing, somewhere in the middle, kinda. But let's look closer. There is no MFA, and critical services are exposed to the internet. And privileged identities are weakly protected. Would you honestly think this platform even moderately secure? I wouldn't. And that realization completely changed the direction of my mini project and those series, because today we are no longer building a maturity scoring tool. Instead, we are building a probabilistic risk model. Sounds fancy, right? So, to make that possible, we need to find a way to encode those security expertise into something a machine can reason about. When I started this project, the goal seemed pretty straightforward. Build a security maturity framework, define those domains, define individual controls inside of those domains, and assign maturity levels from 1 or 0 to 5. After that, calculate an overall assessment, give some recommendations, and honestly, that approach works reasonably well, especially if you are after just the assessment and score your platform your system against one of the frameworks like CIS, for example. But the problem appears when you start looking at security through the lens of risks and the actual business impact. Let's take our example again. Imagine a platform with no MFA, publicly exposed services, and weak identity controls. But excellent monitoring and excellent governance, documentation is top notch, and on top of that, the AI tooling are implemented and very well mature. A traditional maturity model might average everything together and conclude that the platform is somewhere around level 3. The problem is that security doesn't work like that, obviously, and risk isn't addictive. Averages, they can hide critical weaknesses. If you would calculate the average temperature across the hospital, for example, you can get something like 37.1. But that means that somewhere there might be a patient with a temperature of 40, which is very critical case. So in same sense, for the security, some controls matter much more than others. And some weaknesses dramatically increase the likelihood of compromise, regardless of how mature the rest of the platform appears. So you might have an amazing AI tooling implemented for your platform, and that AI tooling probably would scream at your engineers that you need to fix and implement MFA for your identity management, but still that problem exists. Basically, that's when I realized, or on that example, I realized that I was asking the wrong question. The question isn't what maturity level is this platform. The real question for the engineers and for the business is what risks does this architecture create? And eventually, how likely are security incidents that impact the business? This leads us to a completely different model. Instead of assigning scores to individual controls, we start thinking about the cause and effect. For example, disabling MFA is not a security incident by itself. It's not even a threat. It's simply a missing control. But that missing control increases the likelihood of a threat, specifically the credential theft, and the high credential theft probability increases the likelihood of incidents. Things like unauthorized access and privilege escalation and data exposure. And those incidents eventually lead to business outcomes, things like regulatory penalties or operational disruption or just loss of customer trust. Notice how different this from a maturity scoring. Instead of saying that our system is level 3 on network out of 5, we no longer asking that what score should MFA receive. We are asking how does MFA influence risk? And I think that is a much more interesting question to discuss and much better question to provide for your business. And as I hinted in my last video, to represent this kind of reasoning, I'm going to use something called Bayesian network. If you've never encountered one before, don't worry. This is not going to become a statistic lecture because those are boring and hard to understand. At a very high level, and that would be enough for this video, a Bayesian network is simply a graph that represents relationship between different things. Instead of storing a final answer, like with our previous framework, maturity framework, we don't say that MFA belongs to level 2 of the maturity model. We instead going to store how different facts influence one another. A classic example from Wikipedia might be that rain increases the probability of fat grass. It's simple to understand. And in security, we can model those relationships in exactly the same way. For example, we can build a chain like missing MFA increases the probability of a credential theft. Credential theft increases the probability of unauthorized access. And at the end, unauthorized access increases the probability of data exposure. That data exposure, the last node, is basically the risk that business doesn't want to get. And the power of this comes from chaining those relationships together, because now the system can reason about uncertainty. And security, as we all know, is full of uncertainty. You wouldn't really get an answer from a security expert that, your system is absolutely bulletproof, or this system is never going to be breached. It's just not possible, because you don't know about all of those 0 days vulnerabilities and new exploits that can come up from a wild. So we rarely know what exactly will happen, but we can estimate what becomes more likely. And that's exactly what Bayesian networks were designed to do. At that point, we have another challenge. Who actually defines those relationships? Because I could hard code everything into the application, but that quickly could become unmaintainable. Instead, I'm introducing the concept of a security expert or security experts. Each expert owns a specific domain. For example, IAM expert understands identities and why MFA is important, and the network expert, they would understand that segmentation of different environments and network exposure to public internet. What is important about this and why you don't want that. Secrets expert can understand the credentials management and so on and so forth. More importantly, each expert only need to understand its own area, and the IAM expert doesn't care about firewall rules, and the network expert doesn't care about their secret rotation. Their responsibility is very narrow and very focused, given a set of controls to estimate the capability of a specific threat in their domain. So this allows expertise to be separated into manageable pieces, and those manageable pieces can be updated pretty much on the fly because they will be encoded into JSON. And there's still one missing piece because individual experts, as I said, they see only part of the picture, they see a slice of the picture, and their whole security outcome emerge from multiple domains interacting with one another. Credential theft alone isn't a whole story, as we discussed, because if you don't have MFA, but connectivity to your system is limited by physical paths, then it doesn't really matter, probably. And at the same time, if you have your network publicly available, well, that's a little bit less likely scenario, but if you have publicly open network, but in terms of the data, you have nothing in your data warehouse, so your security from the data perspective is top notch, there is nothing to steal at all, then still you have a perfectly secure system. Not usable, but secure. So what I want to say is that we need something capable of combining those different signals together. Above the expert layer, I'm introducing a second Bayesian network, and I'm calling it the security architect because it's a fancy name. Experts estimate threat capabilities, and then security architect combines them together. And from those combined threat capabilities, we can estimate incident likelihood. And then from incidents, we can estimate business outcomes. This is the point where the model starts speaking the language of the business rather than the language of just controls. And that's ultimately the goal. Not your MFA score is 2, but instead the architecture increases the likelihood of unauthorized access and regulatory impact. Now that we understand the architecture, we need a way to represent those expertise. The goal is simple. The Bayesian engine doesn't know anything about IAM. The IAM expert should. So, in the next step, we are going to start encoding the expert knowledge into JSON. Not application logic, not source code, the structured knowledge. The first version will be intentionally simple, one expert, few controls, and a thread capability, and enough information to construct our first Bayesian network. So, today we evolved the project from maturity assessment framework into a probabilistic risk model. We introduced Bayesian network and we introduced those domain experts. Finally, we introduced the second level of the Bayesian network as a security architecture layer. And that connects those technical controls to business outcomes. In the next episode, we will take this expert definition and build the first working Bayesian network capable of performing the inference. And that's where the things start to get interesting, I hope. See you soon.